Hello guys, welcome back to our channel Apna Tutors. So in this video we are going to do more questions related to bijective functions. Now we will have some more functions where we will try to understand their bijective property. Okay, so let's start. So our next question is question 8, where it is given let A and B be two sets so that function from A cross B to B cross A is defined as f of A comma B goes to B comma A. We have to show that this is bijective function. Okay, so for bijective function what we need to do is first we need to show that it is 1 1, then we need to show it is onto. So how we will show 1 1? As we did in many previous video, now we know how to show the 1 1 property. So for 1 1 property what we do, we take some arbitrary point from the domain, but here note that our domain is A cross B. Okay, so how our point will look? Something like A1 comma B1. So we have to take 2 points, so A1 comma B1, and another point is A2 comma B2, and we have to take such that their function value is same, and we need to check whether we are getting that elements as same or not. That is, are we getting A1 comma B1 as same as A2 comma B2 or not? Okay, so let's verify it. First of all, what is f of A1 comma B1 will be by definition of f? It will be second element will change into first element and first element will change into second element, or else component. So f of A1 comma B1 will be B1 comma A1, and f of A2 comma B2 will be B2 comma A2. Now comparing component wise, we get that B1 is equals to B2 and A1 is equals to A2. Is this tells us that our A1 comma B1 will be same as A1 is equals to A2. The first component can be written A2 and B1 is equals to B2, so second component can be written as B2. So we got that whenever we are taking any arbitrary point such that their function value are same, we are getting that elements to be same. Hence our function is 1 1. So we got our function is 1 1. So one task is done. Another task is to show it is onto. Okay, so let's show onto. For onto, what we need to show? That for whatever point we take from codomain, here our codomain is B cross A, we should find some point from domain whose image should be that element from codomain. In the sense, what I am trying to say, if we take some element from the codomain, that is, let A comma B belongs to codomain, that is B cross A, we need to show there exists some C comma D belongs to domain, that is A cross B, such that image of that element C comma D is same as our element from the codomain, that is A comma B. So our ideal choice here is to, because function is defined, function is doing what? It is reversing the element. So what we should do? We should also reverse the element, then we'll get a required element. So take C comma D as reverse of this element, that is B comma A, that is C equals to B and D equals to A. Then if you check f of C comma D, what it should be? It should be D comma C. And from here, that is from, let be equation 1. From equation 1, what we are getting? D to be equals to B and C to be equals to A. That means D to be equals to A comma B. So are we done? Yeah, we got the point for which image of this element is that are required element. So we are done, right? So we got that our function is onto. So we had shown function is 1 1, and now we had shown that it is onto. So we got that our function is bijective. First of all, it is onto, and so bijective. Not only due to onto, but also due to 1 1. 1 1 and on 2 gives that our function is bijective. So let's move to next question. Okay, so next question is, our function is defined from n to n, defined as f of n is n plus 1 by 2 when n is odd and n by 2 when n is even. We need to see whether function is bijective or not, that is whether it is 1 1 and onto or not. So if we saw one of the property that it is not 1 1 or it is not onto, then we will be done, right? Because for bijective we need both 1 1 and onto. So let's try to show it is not 1 1. Why I am saying like this? How you will get that it will be not 1 1? Suppose I will show you here something. Suppose we want to show that it is not 1 1, then what should we get? We should find some two different element from the domain whose image should be same, right? Suppose I am taking some different element n1 and n2. Suppose for now that both are odd, so we should find some n1 n2 such that, and suppose both are odd, such that their image is same, that is f of n1 equals to f of n2, and here n1 is not equals to n2. Okay, f of n1 is equals to f of n2. We are going in reverse way, that what we want to show we will try to assume that, and from that we will try to find some condition. So f of n1 will be n1 plus 1 divided by 2, and f of n2 will be n2 plus 1 divided by 2. Are we doing right? So n1 plus n2 divided by 2. Okay. If I think if we take both as odd, our work will not be done. We should take one of them to be even and other to be odd. So let's take this to be even. That is n1 is even but n2 is odd. So because if we take odd, then we will get n1 equals to n2, but we don't want that. We want some contradiction. So that is, we want that n1 should not be equals to n2, but f of n1 should be equals to f of n2. So suppose n1 is odd, so what we'll get is n1 is even, so what we'll get, f of n1 is n1 by 2, and n2 is odd, so what we'll get is n2 plus 1 divided by 2. We want this to be equal, then we should have n1 to be equals to n2 plus 1. So we should select n1 and n2 such that this relation should be hold, that is n1 should be equals to n2 plus 2, where n2 is odd and n1 is even. So take n1 as we want n1 to be even, right? First we should take n2 to be odd, right? To take n2 equals to 1 and n1 equals to 1 plus 1 2, right? Because we need to hold this equation. Then what will be f of n2? It will be, as it is odd, so it will be 1 plus 1 2 divided by 2, that is 1, and f of n1 will be 2 by 2, that is 1, which shows that f of n1 equals to f of n2, but n1 not equals to n2, which shows that our function is not 1 1, which shows that our function is not bijective, which shows f is not 1 1 and hence not bijective, right? Did you got it? Yeah. So what we did in this question, we were asked that whether our given function is bijective or not, that is whether our given function is 1 1 and onto or 1 1 and onto or not. What I did is I had shown that it is not 1 1. How I shown that? I have showed you intuitive idea here, right? Intuitive idea here, that what should be the way to think, what element you should take by which you will get some contradiction. So are we done, right? We had shown it is not 1 1, so our function is not bijective. Okay, so let's keep this much for this video. In next video we will try to complete our exercise. Till now keep practicing and work hard. Thank you. Have a good day.